video is going to talk about rational functions. A rational function is a function that's made up of f of x divided by g of x. They're both functions, and because you can't divide by 0, we have to make sure that g of x is not equal to 0. Which brings us to the domain. A domain of a rational function is those values in the denominator that would cause it to be 0. So we have to restrict those values. And this can be done either with a table or with symbols, and we'll do both. So when we look at this function, when we're trying to find the domain, we really care about what's in the denominator. But this particular time, I want to show you how to use your calculator to help you find that. So if we do that, we need to put the whole function in our calculator. So I have more than one term in the numerator, so I have to put parenthesis x plus 5, and then close the parenthesis, divided by, and then parentheses again around my denominator, x squared minus x minus 20, and then close my parenthesis. And when I go look at my table, I'm really looking for values that are going to give me this error. Okay, so I have an error at x equal -4. And if I bring my calculator back up and go the other direction, in fact, if we start at 2, we can see the other error here at 5. So we also have an error at x equal 5. And it's the error that is the important part. That tells us that x cannot be -4 and it cannot be 5, or else we will have something undefined. So the domain is all reals except for these values. And I'm fine if you tell me the domain is just x can't be those things. Then we understand that x is everything else. So for this one, we're going to do it symbolically. So we only care about the denominator when we're speaking about the domain. For doing other things, the whole fraction will be important. But for the domain, this is the important part. And we're really saying 3x squared plus 2x minus 5 cannot be equal to 0, or it would be undefined. So we have a quadratic that is sort of equal to 0. So we can factor it, and I'm just going to do trial and error here. So 3x and x, and I need factors of 5 that will give me 2, and it's a -5, so that tells me that I need to have 3 and 5, the difference would be 2. So I need a +5 and a -1. So I set these now equal to not 0. And 3x will be not equal to -5. And x is not equal to -5/3. And over here, the easy one, let's start it this way. X minus 1 cannot be equal to 0. So if I add 1 to both sides, I find out that x cannot be equal to +1. So my domain is all values except for these two. Some rationals can be simplified, and we are looking for common factors when we simplify these between the numerator and denominator, because remember, if you have a factor on the top and the bottom, they cancel each other out because they just become 1. So when you look at 32 x to the 12th and 24x to the 9th, I'm looking at that and I'm saying, well, 24 and 32 both have 8 in common. This would be 8 times 4, and then I've got my x to the 12th. And 24 would be 8 times 3, and I've got x to the 9th. So my 8's cancel each other out. That leaves me number-wise with a 4 and a 3. And then remember that all of these are going to cancel out 9 of those. So take 9 of them off, and we find out that we have x cubed. Now when we look at this one, we have polynomials in both parts of our fraction. But that's all right. We just factor everything. So x plus 5x minus 5 would be x squared minus 25. Remember, that's a difference of squares. And on the bottom, factors of 15. I just need the factors of 15 because it's an x squared first. So factors of -15 that will add up to -2 sound like, again, 3 and 5, but this time we need it to be a -5 and a +3. And that'll give us -2. So x minus 5s are both ones on the top, ones on the bottom. And we're left with x plus 5 on the top and x plus 3 on the bottom. And finally, we have something a little bit bigger. So what can we do here? Well, let's try our factoring. And I'm going to start with the top one, and it's rather big, so I'm going to come and do my x factoring. 12 times negative 3 is negative 36. And we need to add up to 5. And I happen to know that that would be a negative 4 and a positive 9. Just know that one. I don't know why. So 12x squared, then remember you rewrite your middle term with those two facts. So minus 4x and plus 9x. And then we're back to our minus 3. And we take the greatest common factor of 4x. So it leaves us with 3x minus 1. And then we come over to the second set. And 9x and negative 3 have a positive 3 in common. And then that leaves us with 3x minus 1. So on the top here, we're going to have that common factor of 3x minus 1, as well as the factor of 4x in red down there, plus 3, the leftovers. And then this one, we're going to factor, and I think those are small enough that I probably could trial and error this one. So 3x and x, and then 2 is the only possibilities are 2 and 1. We just have to decide which one's negative. And if I'm going to get up to a 5, I better combine my 2 with my 3 here to get 6x. And it would be the big one, so I want that to be a positive 2. That makes this a negative 1 here. And you can see that the 3x minus 1 and the 3x minus 1's cancel. Now, you have to do a lot of factoring with these kinds of problems. Let's look at one more problem. This one, if you look at the denominator, it has kind of a goofy looking denominator because the variable isn't first. So what do we do about that? Well, let's go ahead and start factoring. At the top, we take our 5 times the x minus 4. And then we look at this one, and it looks like we have at least a 2 in common. And if we have 2 in common, then that gives us 4 minus x. And if we look closely at these two factors, this is positive x and a negative 4, and this is a positive 4 and a negative x. So they're opposites of each other. So all I really need to do is factor out a negative, and that'll change the signs on everything. So I make this a negative 2. This becomes a negative 4 and a positive x. And if that bothers you, you could rewrite it as x minus 4. And now we see that we have a common factor on the top of x minus 4 with one on the bottom of x minus 4. And we're just left with 5 over negative 2.